All right, guys. Sorry I couldn't be there today because I have a workshop. All the chemistry teachers and physics teachers are at this workshop, so there's a lot of science teachers out this morning. But I just wanted to run through some example problems with you guys before I let you loose and you try a bunch on your own. Your goals for today are to finish the rest of these problems you see here and to do those practice multiple choice questions. And I'm going to encourage and please ask all of you to do those multiple choice questions alone so we can work on them by ourselves. Treat it like an AP classroom assignment where you work on those multiple choice questions, hopefully by yourself, so that you try to gain a better understanding of the material we are doing. So when we get there, try those multiple choice questions by yourself. I would really appreciate that. Ideally, try to self-time to make sure you're doing okay. Try to not use a calculator to make sure that you're doing okay, etc., etc. Anyway, why don't we just kind of dive right into this? So, the first problem says write the equilibrium expression for the solubility product constant, which is KSP, for AgBr. So, the equation for when you dissolve AgBr in water, we have solid AgBr. It's going to reach equilibrium because most silver compounds are not soluble, especially the silver compounds with group 17, so AgBr, AgI, AgCl. It's a very, very, very weak electrolyte. So you put it in water and it's going to split into silver ions and bromide ions. So the KSP expression for this would be the concentration of your silver ions times the concentration of your bromide ions. And it's as simple as that. So there you go. That is the equilibrium expression for the solubility product constant, also known as KSP. So anytime it asks you to write an expression, it just wants you to say K equals whatever. Don't plug in the numbers. Just what does K equal? What does it represent? It's not given to you in the problem, but the KSP for AgBr is 5.0 times 10 to the negative 13. So what is the molar solubility, aka the maximum molarity of silver ions in a saturated solution of AgBr? So if we could dissolve as much AgBr as possible and all of it would dissolve, how much ions would you see in solution? So they're all in 1:1:1 ratios. So we just get 5.0. I can write 5.0 times 10 to the negative 13 equals x squared, because again, they're just all in 1:1 ratios. When you square root both sides, you will get an answer of 7.1 times 10 to the negative 7th molarity. So, simple as that. Not too bad. What is the molar solubility of AgBr in a 0.015 molarity KBr solution? So let's rewrite our expression. Ag plus ions plus Br minus. We ignore AgBr initially because it's solid. So all of these compounds are salts. They're solid ionic compounds. So we will always ignore them when we are doing these ice tables here. Silver is going to be 0. However, the bromide ion is going to be 0.015 because we have a common ion. We have mixed it with another salt that is soluble that has an ion in common with the salt that we're concerned with. This will go up by x to make x. This is also increasing because it's a product. So this will be 0.015 plus x. In this instance, since our k is very, very tiny, it's 5.0 times 10 to the negative 13th, we can safely say we can ignore that plus x, and we will have 0.015x. So you divide both sides by 0.015, and you should get around 3.3 times 10 to the negative 11th power. If, again, I can write. There we go. So it changes a little bit when you have an ion in common. And in this instance, it's gone down pretty significantly. All right, next. Would a precipitate be observed if the following were mixed? 100 milliliters of 1.5 times 10 to the negative fourth molarity silver nitrate and 20 milliliters of a 5 times 10 to the negative fourth molarity NaBr. So, what this is asking you to do is to calculate Q. So, before we reach equilibrium, we need to determine what Q is, and then we will compare it to our K. And then based on the very last thing we did yesterday, and I know yesterday's was kind of hectic. In fact, this whole week's been kind of hectic. We might have missed that part. So we will revisit that idea here. So if we were to calculate this right now, if Q were to equal K, we would say it was at equilibrium, and therefore it's completely saturated. We have dissolved the perfect amount. We would have dissolved exactly what we calculated in number 2. So if we get what we solved for X, if our Q would equal K, then we have dissolved the maximum amount of AgBr and it would be perfectly saturated. If our Q would be less than K, then our solution is unsaturated, which means we can dissolve more. And if our Q is greater than K, that means a precipitate has formed. We have attempted to dissolve too much, and any extra you attempt to dissolve, anything extra above that 7.1 times 10 to the negative 7th molarity that you try to dissolve won't. So, first thing we have to realize is we have a dilution occurring here because you are mixing, again, 2 solutions. So anytime you're mixing solutions, they are going to dilute themselves because you're going to increase the amount of water they are in. It's not a big dilution. You're going to notice that the molarities don't change that much because they're, at least for AgBr in this case, because it's just going from 100 milliliters to 120 for silver, but it's a dilution nonetheless. This is a double replacement reaction. So we have AgNO3 reacting with NaBr. We get our AgBr possibly precipitating. That's what we're going to figure out. And NaNO3, which is always soluble. So this is a good time to practice your net ionic equations. We know that group 1 atoms, or ions I should say, are always going to be soluble in solution. NO3 is nitrate. That is always soluble in solution. So we're trying to see if we are going to get a precipitation reaction occurring. And to determine that, we are going to end up calculating Q. So, first, we have to calculate the concentration of our silver ions in solution. So we have Ag plus is going to be equal to the concentration of Ag times its volume divided by the total volume it is at. I converted these to liters. You don't have to. You can keep it in milliliters for this dilutions formula. I just, for whatever reason, felt like converting it to liters. And I'm going to do the same for bromide here. 0.12. Again, that volume on the bottom is 0.12 because you have mixed 100 mils with 20 mils, so your total volume is now larger. For the silver ions, you're going to wind up getting 125 times 10 to the negative 4th molarity. For the bromide ions, you're going to end up getting 8.33 times 10 to the negative 5 molarity. So, remember, all that Q is what K is, not at equilibrium. So K is the products divided by the reactants, all multiplied together, raised to the power of their coefficients at equilibrium. Q is the same calculation when you're not at equilibrium. So if you multiply those two concentrations together here, because that's how our K is defined, is multiplying those two concentrations as we've done above, you will get 1.0 times 10 to the minus 8. Our K is 5.0 times 10 to the negative 13th. Therefore, our Q is greater than our K, and a precipitate will in fact form. Not a PowerPoint, a precipitate. Last question on this page, and then you will be on your own. A person, surprise, surprise, not a robot, adds solid AgNO3 crystals into a large beaker containing a mixture of 0.0022 molar KCl and 0.001 molar, KBr until a precipitate forms. What precipitate forms? AgCl or AgBr? All right, should be worth noting that the KSP for AgCl is, 1.8 times 10 to the negative 10th power. So what we have to do here is figure out who's going to precipitate first and justify how we figured out that answer. So why don't we do AgCl first? So 1.8 times 10 to the negative 10 equals. So we're mixing KCl and KBr with AgNO3. The issue here is we don't know how much AgNO3 we added to begin with, so we don't have a starting place for how much silver we have. We have a starting place for how much chlorine we have. We have a starting place for how much bromine we have, but we don't know how much silver we have. However, at equilibrium, we can, in fact, calculate that based on what KSP is defined as. You know it's going to be defined as the silver ions times the chloride ions. And for AgCl, you have added 0.0022 molar chlorine ions to that solution, and you divide both sides by 0.0022, and you will get a concentration of Ag plus equal to 8.2 times 10 to the negative 8th molarity. You will do the same thing for AgBr. So we have 5.0 times 10 to the negative 13th equals Ag times 0.000. I'm running out of room. 1. Divide both sides by 0.00011, and you will get a concentration of Ag here. And again, this is for AgBr of 4.5 times 10 to the negative 9 molarity. So we have to figure out who will precipitate first. And I would say that the AgBr would precipitate first because this number is smaller than the concentration of Ag in regards to AgCl. So if we think about both of them reacting, we think about an ice table right here. Silver is going to start at a concentration of 0 before you reach equilibrium for both of these. Eventually, it will change by some amount and you'll end up at X. In the case of AgCl, we have an equilibrium concentration of 8.2 times 10 to the negative 8 molar. AgBr is about 10 times smaller. So since the molarity is smaller, you will reach the point of saturation for AgBr first, and therefore it will begin to precipitate before AgCl. So the correct answer here, the precipitate we would see, is AgBr. Before you go on your own, I have a few K values I need to share with you for some of these problems. For number 6, if you flip to the next page, your K value in number 6 is 2.4 times 10 to the negative 5. That's KSP. In number 7, your K value is 3.9 times 10 to the negative 11th power. And I think that's it. Yep, that's all you should need for the rest of them. And that's it. I just wanted to do these problems with you. Feel free to complete the rest of them on your own. It should take you no more than half the block to finish it. So I'm going to say no more than like 30 minutes to do these. Probably maybe a bit less for some of you. Maybe a bit more is okay. But we should have enough time to finish the rest of these and do the multiple choice questions that will be passed out to you. Obviously, we're at the end of the video. If you needed to rewind, I encouraged in my plans that if the video need to be paused, let one of you speak up and we can pause it so you have time to write. If you need to rewind this video, feel free to rewind now. Aside from that, have a great day, everyone, and I will hopefully see you on Monday.